Okay, so like I said, math one, all of this is pretty much linear. So we're thinking like solving equations, parts of equations. And I tried, it's all the exact same content. So do you understand the slope? Do you understand the y-intercept? And then what they mean. So, and by what they mean, sort of that the rate of change. So slope is rate of change. Y-intercept is your initial amount. And all of that. So all of this is that. It's as simple as that. It's just interpreting the question that they ask. But if you know, like if you can in your brain get down to all I have to know is slope, which is your rise over run, or like I said, rate of change. So rate of change, if we're thinking of word problems, would be price per topping on a pizza, price per mile in a car, things like each topping on the pizza. I'm trying to think of all the words that they use for rate of change. Still slope though, so where you can see that it is all connected. And then your y-intercept again is going to be your initial, like I always call it, the butt sitting fee, or your plain cheese pizza fee before you start adding stuff to it. It's also where x is equal to 0. So I tried to break it down so you could see all of the things, and it's all mixed up because that's EOC like, but hopefully you'll start to pick up the pattern. So the very first one is probably really not EOC like, but I want some vocabulary, some call outs, and some highlights that will make your life easier in the future. So we're going to find the equation. Obviously, you can use your calculator and do L1x, L2y, stat, calc, your linear regression, stat calc 4, and then it'll give you all of those fun things. This is indeed a linear regression. It's not, strong or weak. It's not a correlation. Like it is a linear regression because it said so. So from the table, though, things to call out. As soon as you see x equals 0, know that this is your y-intercept. As soon as x equals 0, that is your y-intercept. And that will always be your target in the tables. And your target in general, if they give you the equation, what is, when x equals 0, what is y? That is your y-intercept. Because remember, on your y-intercept, you don't go left and right at all. You just go up and down on your y-axis, because that's what y-intercept it is. It is where the line touches the y-axis. So with that said, backwards, not as hugely important for writing equations, but just fun to know kind of stuff. It works interchangeably. So when y is equal to 0, this is your x-intercept. So this is where this line is going to cross the x-axis. So should you have to graph it, I think I can zoom in a little bit because I don't know if you can see everything I'm writing. All right. Hopefully that's helpful. So those are two really important things. Your rate of change, remember, is rise over run. So rate of change or slope. I really like the word rate of change because I feel like it's more pertinent to word problems, and we have more problems with word problems, typically as students. Problems with problems, go figure, right? So it's rise over run, and that rise over run means who goes on top, y or x? Think our trampoline story. So rise over run or slope, who goes on top, y or x? Yes, y, good. Tall and skinny, crazy, little short, wonky, because this is our trampoline. So y is on top. So you can also find your slope by making a pattern in the table. So how did I get from -3 to 0? So if you're sitting on a number line, if you think elementary, middle school, around the top of your classroom, maybe at some point, you saw a number line from negatives to positives. How would I get from -3 to +0 or 0, neutral 0? See, how can I answer? How, like when you have x -3, how do I make that -3 turn into a 0 to move it to the other side of the equation? Yeah, we're going to add 3 because that's like an add 3. And then 0 to +3, again, we added 3. 3 to 6 is add 3. 6 to 9 is add 3. So the consistent pattern in our table is add 3 on the y side. So when I'm looking at my y over x, we know that's going to be a +3. Then you want to always check your x. Ideally, best world, it's 0, 1, 2, 3, 4, which is just add 1, add 1, add 1, which means it's 3 over 1. But that is not always the case. And you want to check it because if it goes by 2s consistently, that's fine. 3s, 8, 9s, 10s, whatever, as long as it's consistent. If it is not consistent, that is when you have to use the stat calc linear regression because you don't have a consistent amount of information. So it is a little off. So that would never be a calculator inactive question. It would have to be a calculator active question if your X values are not that consistent. And it doesn't have to be 1. It could be whatever number. But if every time is not the same number on the little arrow, like I like to call them, then you would need to use your stat calc and then do linear regression. So if we're writing this equation without a calculator, you've already got the important things now. You have your slope and you have your y-intercept. So then we're going to simply put it in y equals 3x minus 3. Another very important call out I've noticed on our ed puzzles. If you leave off the x, it is not linear. Because y equals 3 minus 3 is y equals 0. That is a horizontal line, because our HOI, so that's a horizontal line passing through 0. That is not the same thing at all, or even close, to y equals 3x minus 3. Because 3x minus 3 means it's going to start on the y-axis at a negative 3, then it's going to go up 3 over 1, up 3 over 1, so it's going to be shaped something like that if we were to graph it in Desmos or on a piece of paper. So again, just some call outs. Also to remember X and Y, which is my input? X or Y, which is the input? Good, Maddie. Good, good, good. So input is X because that's what you plug into the equation. And if that's input, then Y is our output because that's what comes out when you solve it. Here's another one for you, vocabulary, vocabulary, vocabulary. And I did get a question that asked, why is vocabulary important? I wish we were in person because then I could giggle at you, like literally in your face. Vocabulary is important because if you don't know the vocabulary, you don't know what the question is asking for. And as I've said numerous times, Math 1, some of the problem is just that they use so many different ways to ask for the same math. So if you don't know the vocabulary, you don't understand that you already know the math, which is harder than vocabulary for most students because most students say they're not mathy people. So in that case, it's not words that are a problem. But I have found that most of you can do the math if I translate what the words are saying to a more like not mathy sentence. So if X is input and Y is output, which variable is independent? So independent is IND, which I'm hopefully we already know that. But independent is going to be X. Good. So independent. It is not controlled by anything other than you decided. Like that is what you decided. So it's independent. Y depends. So it's dependent on what X value you plug in. So independent is X, dependent is Y. Also, hopefully, if that doesn't stick, you have N and N. So if you got input, then you know that X is going to be your independent variable because it's inside the equation, which means it's the input. And again, in the equation, and that word would be for slope-intercept form. Because otherwise, if it's in standard form, X and Y are on the same side, and that's not as helpful. But that's why I always say that slope-intercept form, which is that Y equals mx plus b, is my favorite because you can tell a lot from it. So super basic, not EOC-like, but just lots of fun vocabulary, again, hits. Number 2, this is jumping a little backtracking, but I love this because you would panic, and there's no reason to panic. The lengths of 3 sides of a triangle, so 3 sides sounds important to me. So 3 sides of a triangle are consecutive odd integers. Ding, 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 ding. That's my what do I do? Consecutive odd. So consecutive odd, remember we have the X. And since it's odd, what's the second one if I was to list it? So if I wanted to go from 1 to the next odd integer, what would I do to 1? And we need 3 of them, so I'm going to do the next one. So X would be 1. What is the next odd integer after 1? Yes. So if this is 1, and we're making this up right now, if I wanted to get to 3, how did I get from 1 to 3? Yep. So we're going to add 2. So that's going to be our second integer. And then after 3 is 5. How did I get from 1 to 5? Yes, good. So disregard my 1, 3, and 5 because we just made that up. Remember, this is our list for odd and even integers. Now we're going to go back and continue reading. And literally, guys, when I do these problems by myself, this is what I do because, as I've said before, I have the attention span of a squirrel. And when they start getting wordy, you lose stuff. So I start at the very beginning, and then I just start like highlighting things that I know are important. Consecutive odd is what I'm going to do. 3 sides, it is a word 3, but 3 is a number. I feel like that's important. So I would highlight it with a highlighter. If the perimeter is 63 inches, so perimeter means sum of all sides, right? Is means equals 63 inches. Find the value of the shortest of the 3 sides. So shortest of 3 sides is going to be what I do at the very end, shortest. So that very last sentence or last portion, it's always what it's asking for. I usually read it straight through like I did, but then I'll go back and read it at the end. So I have 3 sides. Those are my 3 consecutive odd. That's why I have a 2 and a 4 instead of a 1 and a 2, and it's going to equal 63. So x, and we're finding the perimeter. So we're adding them together. And then we're going to solve for 63. So first and foremost, we want to clean up on one side all of our like terms. So we have 3x's, which is going to give us 3x. 2 and 4 are both constants, so we can add those together and get plus 6 equals 63. I'm solving for x, so I need this guy by itself. What am I going to move first? To get 3x by itself, what am I going to move first? The 6, yes. How am I going to move the 6? Good, subtract 6. Beautiful. Subtract 6, subtract 6. So now I have 3x equals 57. And we're going to divide by 3. So 57 divided by 3 because that's the inverse of multiplication. And that's going to give me x equals 19. Now, so divide by 3. X equals 19 is going to be the smallest one because that's our x. So this is 19. So we know this is 21 because when we add 2 to 19, we get 21. And then we're going to get 23 if we add 4 to 19. So that's our list of numbers. Find the value of the shortest of the 3 sides. So what is the shortest of the 3 sides? Yep, 19. Which in this case, you did come up with it when you did your math, but be careful because that is not always the case. And that's why I highly recommend just always making your list of 19, 21, 23 in case it messes up. I did go back and look at that question we discussed before on the last quiz and said, oh, maybe I was wrong. I wasn't. We did mess up. Everybody chose the answer that I said we would choose. When they're negative numbers, remember, the smaller the negative number, the closer to 0 it is. So negative 19 is larger than negative 22. But sometimes we get confused because we see that negative 22 and we think 22 is bigger than 19, but negative works opposite. Opposite. Oh, good. I just said opposite. Made me think of another question I got since we're on our live class. Opposite, reciprocal. Opposite is positive, negative. Reciprocal means flip the fraction. They are not the same. Opposite reciprocal is not the same thing as opposite because there's a whole other word attached to it. Opposite is just simply positive and negative. Reciprocal means flip the fraction, and you have to have them both for perpendicular line slope. So opposite and reciprocal. And sorry, I'm just popping in some little fun facts in the middle as I think about the things that I've been reading this week and last week. All right, number 3. Phyllis is going ice skating. The cost to rent figure skates for X hours is given by the function f of x equals 150x plus $2. So first, before we even attempt this question, because the more practice, the better, looking at y equals or f of x equals 150x plus $2. Sorry, I'm just seeing your question, going back. So if it's negative 5, 6, and you flip it, it would still be negative, just 6 over 5. Right. So reciprocal would just be negative 6 over 5. Opposite reciprocal would be positive 6 over 5, which If you think about it, fractions are a little harder. But $2 flipped would be 150. So that would just be, I'm sorry, 1/2, which would just be a reciprocal. And having 50 cents rather than owing someone 50 cents are very different. So opposite negative, positive, negatives, very different numbers. Flipping them. So like 2, like I said, if you flip it, having $2 or having 50 cents is 2 totally different conversations. Okay, so back to number 3. Looking at the 150x plus 2. What is my y-intercept or my starting rate in this equation? Initial amount in $1.50x plus $2. Yes. So this is my y-intercept, initial amount. That means no matter what, when you walk in the door to get figure skates, you are going to pay $2. No matter what. Then I have $1.50. So what does that $1.50 mean? Likely. If X is hours, what does $1.50 mean? Per hour, right, exactly. So we're going to pay $1.50 per hour. So it's the cost. Money is going to give you the cost for renting the skates. Your X would be our time, right? Because that's how long you rented the skates. So X is going to be time. And that's how you would end up with your final cost at the end. So if we're renting hockey skates for X hours is how you know that that's time. So for X hours is given by the function h of X. And the f of X versus h of X is just saying Frank Henry. In this case, it's probably figure in hockey. So it's just noting 2 different equations. It's still the equivalent of y. So it's still your output, f of X and h of X. That spot is still your output. Is $2x plus $1.50. So what are you going to pay for hockey skates no matter what? You will not get out of it. If you want hockey skates, you have to pay how much? Oh, yes, your initial amount. So think about it. When you walk in to go get skates, you have to have you have to know that you're going to have a certain amount of money in your pocket, no matter how long you're going to skate. And that's always going to be that initial amount. So 150 is your initial amount or your y-intercept if we're talking about graphing it. Word problems, I think initial amount sounds a little better. Like I said, your butt sitting fee, non-negotiable. How much are hockey skates per hour? Yes, because I said per hour. An hour is X. So think of $2. 2X is 2 per hour. So that's going to be your per hour would be $2. And then again, X is still your time. If Phyllis rents skates for 3 hours, how much cheaper would figure skates be than hockey skates? So we're going to take that 3 and plug it in where? Is that X or is that Y? All right. Let's go figure skates. This is going to be hockey skates. All right, so the question was, will 3 hours be X or Y? Right, it's X, good, because it says 3 hours. Hours is time, right? So we know X is hours, X hours, 3 hours. The output, because it's money, 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 our output when we solve it is going to be money. So this is equal to money, equal to money. Your Y spot would be if Phyllis spent, and they gave an amount, the question would be how long did they skate for? That would be your solving for X. In this case, 3 hours is given, and we're looking for cost. How much cheaper would figure skates be? That means we're looking for a number, a money amount. So we're going to plug in that 3 in the place of X for both of them. And we're going to solve that. So $1.50 times 3 should be $9. And we're doing this longhand because this could easily be a calculator inactive question because these numbers are fairly easy. So $1.53 times is not $9. $1.53 times is $4.50. Because $1.50 twice is $3, so that's going to be $4.50. Then plus 2, so we got $6.50 for figure skates. How much is it going to cost her for 3 hours on hockey skates? Yes, good. So 3 times $2 is going to be $6 plus $1.50, which is going to cost us $7.50. So how much cheaper would figure skates be than hockey skates? $1. Good. The biggest thing on this one, I would say, number one, is obviously all of your vocabulary and your linear stuff. But even once you get close to that, is making sure you answer the question they ask. Because, you're doing a lot of thinking through this guy. Okay, so number 4. A company rents bicycles to customers. The company charges an initial fee. What's another word for initial fee? Like if we're thinking y-intercept, slope-intercept, y equals mx plus b. What's another word for initial fee? Ooh, close, close, close. What's my other choice? Yes, good. Y. You're just throwing it all out there. Good. Y-intercept. No x-intercept. Y-intercept. And then plus an hourly rate. So hourly rate would be your m, your slope. So hourly rate would be your slope. Because you see the word rate. Rate of change. Maybe that'll help. And that's not always, but usually hourly. So that's per hour. And hour is slope. Your initial fee is that y-intercept, the non-negotiable cost. This table shows the total cost to rent a bicycle for different amounts of time. Now, y-intercept, what is the value of x? So we have x, this is how long hours is how long we're going to do it. So that's what we decide. So that's our input or independent. And then our total cost is the output and depends on how long you're going to skate or rent bicycles. I'm sorry, we switched our stories. For the y-intercept, how many hours would you skate bicycles? How many hours would you rent the bicycle to find that y-intercept? What's your input to get the y-intercept? Every time. We talked about it on the very first problem. Yes. Yes, x is independent and y depends on y. Perfect, perfect. And hopefully, like with the word problems, that makes sense. Your total cost depends on how long you rent the bicycle. Whereas when it's just a table, it's more like you have to memorize. But if you think about the things, what can you control? Okay, so how do I get the y-intercept? The initial fee. For an initial fee, does that mean you actually rent the bicycle for any time at all? No, right. So that means what we're looking for is that 0 in the x column to figure out what is the y column. Again, you could do this if it was calculator active in your calculator in your L1, L2 stat calc lin reg, so 4. But this could easily be a non-calculator active question. So we need to know, again, we're writing our linear slope-intercept form equation. How did I get from 2 to 6? So we're making our little tabs on our table. How do we get from 2 to 6? 4. We added 4. Perfect. How do we get from 6 to 10? Yep, we added 4 there too. So positive 4, positive 4. That's our x. How did I get from 8 to 20? Good, 12. How to get from 20 to 32? Add 12 again, exactly. So, who goes on top for slope, y or x? Good, so we're going to do 12 over 4. 12 over 4, you never want to leave it 12 over 4. We're in high school, we always reduce fractions at this point. So 12 over 4, how many times does 4 go into 12? Because this is exactly like if this had been 12x divided by 4. It would go in there 3. Good. So we got a 3/1 slope. Now you could do 3/1 and plug it in and choose one of these as a coordinate, because these are coordinates. Input, output, input, output, input, output. Like maybe you plug in the 2 in the place of x, and then you solve for b and you get your y-intercept, right? Or you can count backwards. So they skipped, 4 numbers, but every single number is going to be add 3. So if I go from 2 back to 1, I'm going to subtract 3 because I'm going backwards versus going forward. So if I went to 3, like 1, 2, 3, 3 hours would only cost me $11, but I want to work towards 0. So 1 hour would cost me $3 less than 8. So that's going to be 5. So 1 is going to be a 5. 0 hours, we're going to go back a little bit further. So subtract 3 more is going to be 2. If the table expanded, hopefully it would make a little more sense. But if I subtracted 4 from 2, I would end up at a -2, which wouldn't give us what we need. And then again, if you wanted to do y equals mx plus b to get our y-intercept, we can plug in that 3 here. 2 and 8 are my favorite because they're the smallest. So I would use your 2 and 8. So 8 equals 2 plus b. 3 times 2 is 6 equals 8 plus b minus 6. I've run off the page, sorry. And so b equals 2. That is the way we did it last week when you didn't have word problems. You just had coordinates and a slope, or just a list of coordinates in general. Then you solved for a slope. So again, your initial cost at that point, or your y-intercept, is going to be 2. So what is the fee per hour? Because this is a word problem. What is the fee per hour? So when I write this equation, it's going to be y equals 3x plus 2. Per is going to be your important part. Per hour, yep. So per hour is going to be your slope. So it's a $3 fee per hour for your bicycle. What is the initial fee in dollars that the company charges to rent a bicycle? Initial fee, I'll ask it again one more time. What's another word for initial fee? If we're thinking y equals mx plus b. Is that the slope or the y-intercept? Y-intercept, good. That's your non-negotiable. That's your when x is 0. When you do whatever you're doing, you're going to do it 0 hours, which will cancel out whatever the slope is and will leave you with your y-intercept. So in this case, what is the non-negotiable fee that you will pay every single time you go, yep, $2. Perfect. Hopefully we're starting to clear some of this up. Because it's all the same conversation. It's just written in different order. Ooh, that 84 is doubled and should not be doubled. It's because I copied and pasted it from somewhere. So it's only 184. So Jaya is the middle of 3 siblings. This is a math class. So I know 3 is going to be fairly important, likely. Whose ages are consecutive even integers. So I'm going to stop. Consecutive even would be 2, 4, 6, 8. So divisible by 2. So the first one's going to be x. What's the second one we would use since they're even? X plus 2, right? And then x plus what? Good, x plus 4. Because even and odd is x, x plus 2, x plus 4, x plus 6, and then so on, 8, 10, 12. If they were just consecutive, so even or odd was not notated, it would be x, x plus 1, x plus 2, because that's how you get from 1 to 2 to 3 to 4, counting directly. If the sum of their ages is 84, find Yaya's age. And by the way, she is middle, which is going to be important in a little bit as well. So we're going to add them all together. X plus 2 plus x plus 4 is 84. Combine your like terms. So how many x's do we have total? Yep, so we're going to have 3x, and then 2 plus 4 is going to be 6 equals 84. We want to solve for x, so what are we going to move first? Yes, subtract 6. You knew what I was going to ask. Perfect. So we have 3x equals 78. Now what operation are you going to do? Yeah, we're going to divide by 3. Perfect. And so what's our answer? Does anybody know? Good. 26. Now, we have 3 children. So the first one is going to be 26. Then we have 28. And then we have 30. How old is Yaya? Good, good, good. The middle one, right? So 28. So you did all that good math and got 26. Guarantee, I promise, if this is a multiple choice question, they are going to give you a 26 in your choice, because especially on test day when we get all like super nervous and stuff, you're just excited you got a number that makes any sense and you jump. But remember, I cannot tell you enough, Math 1 EOC, we are processing information. So it's not just like a jump, jump, jump. Don't pick an answer until you read the question again, because they ask it. That is the hardest part, in my opinion, of Math 1 EOC. They ask the questions where you have to think about the math you just did, not just do math. Okay? We're going to do number 6, and then I'm going to jump past 7 and 8, because I want to make sure that you understand how easy today's work is, because I know word problems are a drag, and we've been really hard today in our stuff right now. So a group of scientists studied the amount of erosion on a beach. The scientists determined that the equation y equals a negative 0.5x plus 26 models the amount of shoreline. Y in feet, x decades after 1950. So x is time, y is measurement, feet. Which one is input? Which one do you control? X, good. You're going to control how long we look at this. So this is our input. This is our independent variable. It's what we control. X decades. So that's input is time. You decide how long we're going to track the erosion. And Y is the amount of space that actually goes away, erodes. Which statement is true based on the model? The shoreline is reduced by 0.5 feet every 10 years. Oh, another, before we back up. Let's back up a second, because all of these say 10 years. Do we know what decade is? Again, vocabulary conversation. All right, good. Decade is 10 years. A decade is 10 years, just to make sure we're clear. So that's why they all say every 10 years. So per 10 years, kind of like we were talking about slope, right? Per 10 years. Okay, so then the second one, B choice, says the shoreline is increased by 0.5 feet every 10 years. The shoreline is reduced by 26 feet every 10 years, or the shoreline is increased 26 feet every 10 years. What do you think the answer is? A, B, C, or D? Looking at your equation. Okay, so let's look at this equation and discuss it for a second. What's my slope in the equation? Slope is always attached to your x. So slope, or my m, y equals mx plus b, is going to be that negative 0.5. Negative. Increase or decrease if it's negative? Decrease, right? That means we're losing stuff. So if we just know that that is a negative number, we can get rid of B and D. Shoreline is increased. The shoreline is not getting more. Also, back to that, why is vocabulary important? Erosion, that's a loss of beach. Erosion does not mean we're gaining beach. That means we're losing beach into the ocean. So that's just another one of those places that vocabulary might help. Word problems, if you can use as much vocabulary pull back from whatever it's discussing and put yourself in the situation and don't just harp on the math, it helps a ton. So now we're going with A or C. So if the slope is a negative 0.5, and then the y-intercept that leaves us, or the initial amount, what is the initial amount? What's the number? 26, good. Because it's the number at the end, that b, the constant. The word constant might help in your brain too. The number without a variable is a constant. Constantly, no matter what, you're going to pay this. Constant, constant, constant. It does not change. That's your y-intercept. In this case, we're talking about erosion of the beach. So 26 means that it was 26 feet at the time they started to measure it. The beach was 26 feet of shoreline at the time. So then, are we reducing 0.5 feet, or are we reducing 26 feet if we know initial amount is 26 and the slope is a negative 0.5? So it's our answer, yeah, good, 0.5. So our answer has to be A or C. Good, A. By 0.5 feet every, so every is going to be the same as that per, each, 10 years. So every time you see a every, a per, or an each, that is going to be your slope. And hopefully we're going to memorize y equals m slope x plus b. Okay? Really quickly, I know I'm over already, just to jump forward. Today's lesson, what you're going to do today is calculator active. You're going to have two equations. Whoa, those are blurry. Sorry. Y equals a negative 4x minus 5. And then y equals x, or the two that we have here. Negative 4x minus 5. In this one, it's already graphed for you. The solution to the system, so what makes both equations true, is where they intersect. So you are simply graphing these, and if it's not graphed for you, you're going to Desmos, and you're going to graph them and find the intersection. The intersection is what makes x and y true. It has to be of both lines. So not where one touches the x-axis or one touches the y-axis. It's where they cross each other. So the solution in this case is negative 1, negative 1. And that is the coordinate, or the x and y value, that will make both equations true. So like if you plugged it in, negative 4 times a negative 1 would give me a positive 1. I'm sorry, a positive 4. Positive 4 minus 5 gives me that negative 1 y value. Negative 1 equals negative 1. Perfect. Second one, y equals x plus 4. Y equals a negative x. Irrelevant. We're going to go look for our intersection, where they cross each other, and that's a negative 2, 2. And that's just coincidental that they're matching numbers as this. It could be anywhere on the coordinate plane. X value, left and right first, up and down second. So in this case, that means this x value will always give me this y value for both equations. So negative 2 plus 4, does it give me a positive 2? Yes, it does, so that's good. And then our y value is a positive 2, and that's a negative times our x value, which is also going to give us positive 2, positive 2. You are literally looking for when they intersect, and that is it for solving systems graphing.